if you take a class in computer science, um, they'll and you take something like software engineering, or you do UML, which is not uh, a markup language, that stands for Unified Modeling Language. It's something that a guy by the name of Grady Booch came up with as a way of letting companies communicate, how software engineers can communicate with business people, and how business people can collect all of the things necessary to service a client, their client, okay, one of your customers. And so the customer will come in with certain needs. The business people or somebody in the upper management, in management, will see them and talk with them and collect together all the attributes of what it is they need, and then those guys are going to make up a UML chart of what the client needs, and then the engineers look at that and then determine, you know, the certain people come together and create class diagrams or they create a schema to represent the program. Then somebody in the one of the engineers mock up a prototype, and then your managerial people come down and they'll look at the prototype and they say, yeah, something like that, and then take the prototype to the client, and then the client will look at the prototype and they say, no, I really wanted something like this, and then the manager will create up another chart and say this is kind of what they really need, and then the engineers will produce another prototype, and they'll keep doing that until they come up with the exact idea of what it is they need, and then they will generate the application. And hopefully, I mean, until the client is completely satisfied, you know. And at the end of the project, they do a phase called post-mortem analysis, where they kind of collect together all the things that um, in the in the creation of the application or whatever, they analyze what techniques worked, what didn't work, um, and then basically kind of learn from the mistakes, so that the next time around they don't make the same mistakes again, if they made mistakes. Um, so, man, but there's this. What I was really going to talk about was state diagrams, and or just machine state. The reason why, um, if you're at help desk and people call on the phone and they say, "Why is my program in this really strange state?" and I'm really not talking to the help desk person right now. I'm talking to the person who has problems with their computers and stuff. Um, what the help desk person is really going to do is try to debug things, and they're going to try to hone in. They're going to do what they're going to do something. They're going to do a divide and conquer type thing, where they're going to basically cut the problem up into pieces and debug each little piece. Or they're going to, or they're going to, but they're first going to do, before they do that, is they're going to give you the very simple solutions, and that is, one, kill the app, restart it. If that don't work, turn off the machine, turn it back on. And the reason for that is because all applications have bugs, and one of the biggest, most gnarliest bug that there is one where the application falls into a state that the original application designers didn't plan for. And if you deal and this is not, now I'm not really talking to those people. I'm talking to somebody who is a computer science type of programmer. So I'm talking to that guy. Take electrical engineering course, learn about TTL circuits, learn about how to create very simple applications using TTL circuits, and you'll learn about managing managing state. Um, You can do state diagrams on a very atomic level with just bit flags. And when you get into dealing with that kind of stuff, you come to understand uh, what happens whenever a state-based type system. The difference between modal and modeless applications. This difference between state-based, because on a very low level, your solutions on a very low level, you're just using Boolean and very simple Boolean math and stuff to create functionality. Um, the the states, you can see the states that things fall into, and then you can find the states that you never expected for, and then you'll see loops, and then you come to understand that the best solution whenever you create applications to try to minimize the amount of code that is in your application, to try to reduce it to a very atomic type operation. Because if you can and in object oriented programming, how they do that is by abstraction. They try to come up with the very essential ADTs, uh, abstract data types. They try to come up with the most essential ADTs to create the essential operation of what they need in the solution, and then they abstract on top of that. They add layers and layers of abstraction. So an example of that is an RSS feed, a real simple syndication feed. um, the simplest operations you want in RSS is to be able to take messages and put them in a list that people can download, and then experience the messages in time or whatever. That's the very simple of RSS. A podcast is an abstraction from RSS. That's RSS where the messages include little nested objects or nested modules in there that have MIME types. That's a MIME type is a way of specifying what type of data exists in that module. And inside of that, you put pictures, or you put a link to an MP3 file or a link to an MP4 file. And that's how you come up with audio podcasts and video podcasts. All they are is it's just XML with nested, tagged video references and link references, picture references. It's just XML. It's just nested data is all it is. Um, but XML is nice for some things. I've pointed out to people what it's not nice for is it's not nice for interfacing between servers and clients. I would not. I mean, that's kind of the dumbest thing is to use XML. You can do it on websites. The problem is the big problem is parsing the text, because that's going to create a lot of unnecessary overhead. And in the case of something like Corba, um, it's what's called strongly typed, and strongly typed data tends to be super efficient. And whenever you make a request between a Corba client and a Corba server, or a complex peer-to-peer network of servers, um, whenever your client connects with that, it connects with a directory object called an orb, and that orb then manages your session. It manages all the things that you're needing in that session. It creates the environment, and then you interact with that environment, the things that you need to do um, to create. And the difference of that and XML is XML is really just a data. It's a nested data format. It and you could put all your schema of things that you need into that message. That would be a good adequate use of XML, but it's fairly inefficient whenever you're having to do a lot of operations, and that's where you would want something that is basically remote procedure calls. All Corba is an object oriented abstraction of RPC. And people say, "Oh, it's just RPC." Well, you could also say, "Oh, yes, C++ is just C," and you say, "Oh, Java's just an interpretive language that's a top C." You know, you could say that about anything. All object oriented solutions are just abstractions. They're just all they are. They're just structures. They're ADTs with something much more simple and something that's simple, like an assembly language. Or in C, you can create any language in C. In fact, there are courses you can take where they'll teach you how to, say, create a C++ compiler in Pascal. Or, I mean, you can take any language and make it a interpreter or a compiler for any other language. That's and once you learn that, then you start to wonder why Microsoft keeps throwing you on a new language all the time, and then you start to see why you need to get away from companies like that, because what they're doing is they're keeping you dependent. Whenever the solutions, what they're doing is that if they can come up with some sort of unique technology, they'll hide it behind an interface inside of a language, and then they'll force you to learn that language just to access the technology. That's Microsoft OT. They've done it for years and years. It just never, it just never gets any better, because that's their business model, to keep you dependent on Microsoft. Linux's business model is, here's all the things you really need, and nobody really owns it. Everybody maintains it, and it's secure and all this stuff, and we're going to guarantee it's secure. All the corporations rely on this stuff. The good corporations, the other ones are dependent on Microsoft, and they're fucking themselves. Like, I mean, they just don't understand that they're shooting themselves in the foot. The people that are on Linux are like laughing at the people that are on Microsoft, and the people on Microsoft just can't get any better on that. However, every now and then they come up with technology that kind of poo-poos the Linux, and then the Linux crowd comes up with something, or some application developer puts something on Linux that does essentially the same thing as what Microsoft does. When it boils down to what it all boils down to is that if it weren't for Linux, we wouldn't have the freedoms we have on the internet. It just would not exist. And so all Windows is it's really just for the people who can't really deal with the complexity of what the internet is. And Apple is the same way, but both Apple, the smarter people are there, and Microsoft, if they have smart people, they hate their job. Um, they're getting well paid, and that's how they're able to love their job, is they're getting well paid. But the simple of it is that they fucking don't want to be there. I mean, some don't, some do. It depends. Everybody can find their little niche and something they like. Um, Business software, commercial software development can either be good for you if you don't care, but if you absolutely do care, it's a pain in the ass, and you can see that you're just going to keep pushing a boulder up on a hill, and it's going to come right down again, and then you just become jaded, apathetic. You just don't give a shit after a while. And some technology people, as I pointed out to them, this little simple thing is, how much of your managers and your business people who don't really understand technology keep putting more pressure on you every year, and you present a solution and it's better, but then they want more, and they're looking at Moore's law, which is to always want you more. that's it, they don't understand that Moore's law only applies to lithographed chips, the lithographic process of replicating chips, replicating schematics. That's what produces um, the exponential behavior of Moore's law, is the nature of the way binary, is base 2. It's going to go exponential in base 2 every year, because all they're doing is taking is reducing the scale of the chip by using materials and a lithographic process where they're just duplicating the schematics from the previous chip, and now it runs a lot faster. And they just keep doing that and getting better technology to keep reducing it and reducing it. And then they get to this point to where they can't reduce it anymore, because if they did, the electrons would bust holes in the walls, and then you would start having cyclic issues and state problems and stuff like that. So whenever people pump up the clock cycles on their processors, they're challenging the integrity of the chip's ability to maintain state. And whenever you push it too far, then it loses its capacity to maintain the integrity, and your programs crash, and you're burning out your CPU. And basically, the reason why the companies will let you do that stuff is because they know you're in a mode of self destruction on your process. What you're basically doing is you're destroying your computer, and they're just giving you parts to permit you to keep destroying your computer. And so those hackers, those guys that keep messing with their PCs and keep, you know, water cooling and stuff and all that stuff, all they're doing is they're performing this perpetual process of destroying stuff. They're taking money, throwing it into a hole, and covering it up with dirt. You know, they're disposing of money. They're just looking for a way to dispose of money, and the companies are giving you the rope to hang yourself with. It's the same sort of thing. It's the same sort of issue with Michael Jackson and his plastic surgeons. He goes to them. He says, "You think I need more plastic surgery?" And they say, "Plastic surgeons say, sure, you need more plastic surgery." And so they go in, they do more plastic surgery, and they keep doing it until his face is so fucked up, you know. And it's because he just didn't understand who he needed to be consulting with before deciding whether he needed surgery. He was consulting with the plastic surgeons, which is not the people you consult with. Same case with creating your own PCs or something. You don't go over and consult with the people that are selling the stuff to you. The they're going to, if you go down to your local computer store, they're going to soup up their PCs and stuff, but they may try to create something that's overclocked or water cooled and all that stuff. And the reason why they're doing that is to tempt you into doing the same thing, and they're going to give you the rope to hang yourself with. The only people that can really do it are the people that are actual engineers that understand what they're getting themselves into.